Hello viewers and my dear students. Welcome to a demo on one-dimensional problem analysis. Here I'll be showing you a typical demo on one-dimensional tapered bar problem analysis using Ansys Release 14 of Mechanical APDL. You please see here, the problem is this. The problem is this. See here, this is fixed at one end. This is a tapered bar. Please understand, this is the tapered bar and the thickness of this bar is 20 mm. See here, assume thickness as 20 mm. When it is thickness 20 mm, at this point it will be 20 into 20 will be the cross sectional area. At this point it will be 10 into 20 is the cross sectional area. Okay, this is the tapered bar and it has a length of 100 mm and all that. It is subjected to an axial load of 1000 newtons. Okay, in this problem, for the simple tapered bar subjected to axial load of 1000 Newton as shown, determine the following using Ansys Release 14 of Mechanical APDL. This is a typical question asked and you are supposed to find nodal displacements, forces and stresses in each material, reaction forces and all that. Okay. Now whenever a tapered bar is given, see here, this can be done directly using beam 188, assuming it as that is taking beam 188 element, and you can do it as a beam problem later on. But here in one dimensional problem we will have a small assumption here. See here, now this is totally 100 mm. No, this is totally 100 mm. As you see here, this is totally 100 mm. I'll divide into 20 20 20 20 20. Okay, I'll see that this is 20 and this is 10. That's what you observe here. This is 20 and this is 10. Okay. And in between 20, 20, 20, 20, 100, 20 here, here I'll make 17.5, here I'll make 15, here I'll make 12.5, here I'll make 10. Okay. In that way, the cross-sectional area, since the thickness is 20, the cross-sectional area is here 20 into 20. That means that's what they are given, 400 at the root, no? At the fixed end 20 into 20. Okay, in that way it remains the same. Small approximation I've done. By this way you can do it in the examination. Okay, considering it as one dimensional problem only because this has an axial load. Okay, no transverse load and all that. This has an axial load. As a result, you can do it as one dimensional problem only with small approximation. Okay, this is 20 into 20. This you make it 17.5. The thickness is 20 only. This is 15, thickness is 20 only, 15 into 20. This is 12.5, thickness is 20 only, 15.5 into 20. This is 10 and the thickness is 20 only. That means this has a cross-sectional area of 400. This has a cross-sectional area of 17.5 into 20, 350. This has 300. This has 250. This has 200. That means here in this problem, as we have done in the problem 1, here there are no two elements. There it was only steel and aluminum. Now here there is only one material but 5 real constants. One we have to take 400 millimeter square, another 350 millimeter square, 300 and then 250 and then 200 and all that you have to do. Okay, now we will go for solving using Ansys Release 14. Okay, now you see here, now you see as usual you go File, Clear Start. Okay, just say OK. Okay, then File, change job name. As I told you, you should always do this. Tapered bar problem. Okay, just say for new log and error files. Just say OK. Okay, then File, change title you take. Change title. Tapered bar problem. Okay, here this you do, then you just say fit, you get this tapered bar problem you get. Okay, now you see here preferences, structural, okay, okay, then preprocessor, element type, add, edit, delete, add, link, this 180, link 180 you take. This link 180 has come, just say close. Okay, now as you see here, there are 5 real constants. Now see here, link 180 I have chosen. Now 5 real constants have to be fed here. Real constants you see here. Add, edit, delete. First one, add. Okay. Then real constant 1, as you know, it is 400. Okay, 400 you put. Let's say apply. Okay. Then you put 2. Then you just say 350. Apply you do. Then 300. Okay, apply you do. 4 you take. 250 you take. Apply. Then 5 you take. Then 200. I think these things are clear, pretty clear. Okay. Then say here, 1 here, 2, 3, 4, 5. 5 real constants have been made. First real constant has, if you say edit, no. If you say okay, it is 400, correct, no? In the same way, if you take 2, if you take edit, it is 350. In that way, 400, 350, 300, 250 and 200. 5 real constants have been fed. Okay. Now you go for material properties, material models. Please understand here, the entire tapered bar is steel. That is why elastic, isotropic, you feed only 2E5. Okay, 2E5 because everything you are doing it in Newton millimeter square only. Just say 2E5. That means for this model, there are real constants of 5, but material is single. That is, material is only steel. Okay, this you understand. This you see isometric. This is 2E5 only. What we have, if it is correct, then material exit you do. Okay. Then you go for modeling. Create key points in active coordinate system. You see here. First one. You see here 1, 0, 0, 0. Okay. As you know, it's the first one. I have divided that 100 mm into 20, 20, 20. Okay. That is why now 1 is this. Apply you do. Then just take 2. It is 20 you take. 20, 0, 0 you take. Then they apply. Then you go for 3. 40 you do. Apply you do. Then 4 you take. 60 you take. Then you take apply. Then 5 you take. Make 80. Apply you do. Then 6 you take. Make 100. In that way, you have created 5 elements. Okay, 5 elements. 1, 2, 3, 4, 5, and these are all the nodes created and all that. Now I'll join by lines. As you know, create lines, straight line. Join this to this. Join this to this. This to 3 to 4, 4 to 5, 5 to 6. Now, as you know here, this you be careful. I have just joined by lines. And this is, entire thing is only one material, that is steel, 2E5. Okay, but this has different cross section, 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 and this has different cross section. Okay, in that way, as you are aware, this is 400, this is 350, this is 300, this is 250, this is 200. Those things have to be fed down. Now you go for meshing, mesh attributes. Mesh attributes you take and picked lines you take. Picked lines, first you take this. Just say okay. Material number 1, real constant there are 5, you take 1 only. 1 and 1, that is material is 1, real constant is 400. Just say apply. Then you go for 2, say okay. Material number 1, take real constant 2 here. Then say okay. Then picked lines, take 3, you just say okay, 3 you take, just say okay. Then picked lines, take 4th, you make it as 4, real constant 4, just say okay or apply, anything, okay, okay you do. Then picked lines, take 5, this should be 5th one, 5th real constant. In that way, you just do this, that means This says real constant 1, real constant 2, real constant 3, real constant 4, real constant 5. Then what you do is size control you go, size controls, manual size, lines, picket lines or all lines, anything, okay. Picket lines, you pick all the lines or all lines you can give, okay. Okay. And number of divisions you give only one. That means we will have everywhere one line only. That means only 5 elements we have created, okay. 5 elements we have created. Then we do mesh, lines, okay, pick all you do. Once you do this, you should know that you should have only 5 elements done here. 5 elements, nodes, attributes, real constant, you see. This is very important, you see. If you are gone wrong, you just check. 1, 400, 2, 350, 3, 300, 4, 250, 5, 200. It is perfect now. This you have to verify properly, okay. Once you do this, this is correct now. Now what you do, you go for loading, loads you go, define loads, apply, structural, displacement, on key points, you take this key point, okay, just say okay, and all degrees of freedom, you make it 0, okay. Then, force moment, on key points, you take this, and just say Fx, it is actually 1000 newtons, it is 1000 you take, just say okay in the positive x direction. This is the thing, okay. Now what you have, the it is in this direction, the load has been applied. Then you go for solution, solve, current LS, you do this. Current load step you do, say okay. If you're done correctly, you should get the message solution is done. Solution is done, you get. That means you are in the right track. That means you have applied the load properly, everything is correct. Now we will go for general post process. Okay. First thing what you will find out is list results you go, nodal solution. Okay, this is important. You see here DOF solution, displacement vector sum you say, okay you say. See here, these are all the things what has to be verified. This is first node as you know here. Okay, plot controls, numbering, node numbers. Okay, if you do this, node numbers on. First node it is anyway fixed, it is 0. At 2 it is 0.25 into 10 to the power of minus 3 mm. 0.537 into 10 to the power of minus 3 mm. At node 4 it is 0.869 into 10 to the power of minus 3. And at 5, 0.126690 10 to the power of minus 2. This is increasing here. At this it is maximum 0.1769 into 10 to the power of minus 2. This has to be recorded. This is one of the very important answers. This you take the tabulation, that is you take the printout, or you have to copy down this or make it in a tabular column. This is very important results for us. Then in the same way, reaction solution also you go. Reaction solution, all items you go. Then the reaction solution. If you, since there is only one support at the end, since I applied a load at one end, the reaction should be minus 1000 at this support. That is at node 1 only you have a reaction, that is minus 1000. That is also okay. Then what you do is, then you go for element table, define table, okay, add, you see here, by sequence number, SMISC 1 you take for finding the forces, member forces, then say apply, then go for by sequence number, LS 1, 2 or 1 is enough, 1, 2 also you can put, 1, 2, okay, say this, okay, this you say here, SMISC 1, LS 1. That is, LS is for the axial stress, SMISC 1 is for member forces. Once you do this, then you go for list results, element table data, okay, SMISC 1, LS 1 you take, okay you say, and this is the perfect way. See here, in all members, since it is, there were only one force, member that is forced in every member is same. But these stresses are different. One is 1000 by 400, another 1000 by 350, another 1000 by 300, another 1000 by 250, another 1000 by 200. In that way, everything is proper here. In that way, this also, you make a tabular column and show it to the examiner. Or if you are writing it in the record, this is also another very important solution. Okay, did you follow? These things you should know, and this will complete this problem. Thank you very much for watching. Thanks friends, thank you.